So this is the second day on section 5.2, division of polynomials. Are there any questions on the homework, which was only 18 through 24, and I did several of them on the video yesterday. Which one? 24? Okay, 24 is a great question to do. The trick with long division, or the important part of long division, is you have to have every term represented, every power represented. What do I mean by that? You have h to the fourth, you have h to the third, you have h to the second, you have h to the one, you have the constant at the end. The top is ready to go, right? The bottom one's not ready to go. Why not? Because it's h to the second. Where's h to the one at? It's not there. Okay, so the very first thing to do whenever you're going to do long division, or any division for that matter, is to make sure every power is represented. So in the denominator, I want to rewrite that as h squared plus 0h minus 1 at the very end. So I'm going to rewrite that bottom one as that. So let's do long division right here. We're going to divide the top one by the bottom one. So on the top, we have the 2h to the fourth, we have minus h to the third, we have plus h squared, we have plus h, we have minus 3 at the very end, and on the outside we have that quadratic trinomial, which is really a binomial. The middle term is 0. So you really have h squared plus 0h minus 1. So when I think of this divided by this, I don't think of the whole giant polynomial divided by this polynomial. I look at the first term only. So, and I look at this first term only. So I say h squared times what will give me this identical value, 2h to the fourth. 2h squared, right? Now, where am I going to write that 2h squared? I'm going to write it above the other h squared. You always want to be organized, right? So one thing, always represent your missing values. Like if you didn't have a h squared, you have to put a 0h squared. If you didn't have a h to the third, you have to put a 0h to the third. Right here, we didn't have an h, so we put a 0h. Always put your missing values as 0 on whatever that missing value is. And then when you do find out what you're multiplying by, please stay organized by writing it over that same value. So this really becomes a distribution problem. 2h squared times h squared is the 2h to the fourth that we wanted. 2h squared times 0h, well, that's simply going to be 0. But of course, for the sake of staying organized, we're going to say h squared times h is h to the third. So we put 0h to the third, which is really nothing. And then last but not least, 2h squared times negative 1, that's a negative 2h squared. Everybody with me? All right. And of course, we are subtracting. And when we subtract, we put the polynomial in parentheses with the minus on the outside. That really means that you're going to put a minus right there, and a minus over there. All the signs change. So when all the signs change, obviously these guys cancel out. This one right here becomes a minus 0, but that's still a negative h to the third plus or minus 0h to the third. That's simply going to be the same value, minus h to the third. And the h squared that's positive up here with this positive 2h squared, because the minus changes it to a plus, you're going to have how many? 3 of those h squares, and it's positive. Everybody with me? So once we get this answer down here, what do? We bring this down, don't we? So that's a plus h. And again, you don't look at this whole polynomial and this whole polynomial. You just look at the first term, h squared, and think h squared times what will get us this first exact term, negative h cubed? A negative h, right? H squared times negative h will give me this exact value. So where am I going to put that negative h? Right on top of the other h. You always stay organized. H's are going to be on top of h's, h squares on top of h squares, h to the thirds on top of h to the thirds. Stay organized always. So let's actually distribute negative h times h squared. That'll give us the identical value, negative 8. Wow, I am messing up today. Negative h to the third. And then negative h times 0h, that's just going to be 0h squared, right? Minus 0h squared. It's really nothing there, but we're putting the 0 to hold the value. Negative h times negative 1, that's positive h. And of course, we are subtracting. Put that polynomial in parentheses with the minus on the outside. So this becomes negative, it cancels. This becomes positive, but 0 plus 3 is still going to be 3 of those h squares. So you really have 3h squared. And this one becomes a negative h, which cancels with the positive h. Now, it canceled, and again, there are no h's, but I want to represent that there are no h's, so I'm going to put plus 0h. So whenever there's a missing value, please put the coefficient of 0 in front of it. And last but not least, I'm going to bring down this negative 3. And finally, I'm going to think h squared times what will give me that identical 3h squared? Plus 3h. No, plus 3. I'm sorry, plus 3. So when I multiply 3 times h squared, it'll be that identical 3h squared. When I multiply 3 times 0h, that's going to be 0h again. When I multiply 3 times negative 1, that's going to be a minus 3. I am subtracting, put parentheses around the polynomial with the minus on the outside. And guess what? Everything cancels. The remainder is 0. So what's your answer? It's positive 2h squared minus h plus 3. There is no remainder, so that's it. If I would have had like a plus one, or a positive 1 down here, then I would put plus 1 over the original divisor. But there is no remainder, so I'm done. Got it? Is there any other one that you would like to see from here? Or are we good? I hope we're good. I did cover several of these on the video yesterday, so go back and watch that video if you need more help. Now, we did not do the first half of this worksheet. Okay, I purposely selected the harder ones to do first, and the easier ones we're going to do right now. Okay, number 1, if you think about it, that would be a horrific problem to do with long division. Even though it says long division, don't use long division. Why not? Because imagine that. Well, this would be inside the division box, right? And then you'd have to write 15r to the 10th, but then you'd have to put plus 0r to the 9th, and then minus 5r to the 8th, and then plus 0r to the 7th, plus 0r to the 6th, plus 0r to the 5th. That would be ridiculous, right? Because you have to fill in all those missing values. Remember, long division, you have to have every power represented. The 10, there is no 9, so you'd have to put a 0r to the 9th, you'd have to put a 0r to the 7th, 0r to the 6th, 0. So it'd be ridiculous to do it with long division. So let me teach you an alternate way of dividing a polynomial by a monomial. What is a monomial? When it's only one single term. Down here you have 5r to the 4th. It doesn't say 5 plus r to the 4th. It doesn't say r plus 5 or r minus 7 or r plus 2 or 5r minus 2. It's just a 5r to the 4th. It's one single term. And whenever you have division of one single term, you're able to split that division. Let's go back to the 5th grade and look at something very easy. What if I had 4 plus 8? What's 4 plus 8? 12. If I divided that by 2, what's my answer? 6. So the answer is 6. We already know that the answer is 6. But the reason why I put this simple problem up here is if you have on the numerator any type of addition or subtraction, kind of like you do have up here, addition and subtraction, and if there's one single denominator, as there is up here, one single denominator, you do have the option of rewriting it with the 4 on top of the 2, and then the 8 on top of the 2 as well. You could split the denominator to each one, right? What's 4 divided by 2? What's 8 divided by 2?
4.
What's 2 plus 4? Same answer. Make sense? So we are able to split that denominator, and that's what we're going to do on these problems where you have a polynomial divided by a monomial. Now, if you had two terms down here, let's say it was 5r minus 3, then yeah, use long division. Right? If you have a 2r plus 7, yeah, use long division. But if it's a polynomial divided by a monomial, it's as easy as this. You just split it up. You have 15r to the 10th over what? Over the 5r to the 4th. But then you have minus 5r to the 8th over what? Over 5r to the 4th. And at the very end, plus 40r to the 2nd over what? Over 5r to the 4th. So I took that denominator of that single term, 5r to the 4th, and I put it under there, and under here. Make sense? And now we're going to use the rules of exponents, the canceling rule, to reduce, to simplify these fractions. So what do I have here? I have a 15 up on top and a 5 on the bottom. What's 15 divided by 5? 3. So 15 divided by 5 is 3, and the 3 is obviously left over up on top. How many r's do I have on the bottom? 4. How many r's do I have up on top? 10. So 4 of these r's, all 4 r's cancel with 4 of these 10, and I will have 6 left over up on top. So what's the first term of my answer? It's 3r to the 6th. And then the other fraction, well, the 5 cancels with the 5. The 4 r's on the bottom cancel with 4 of the 8 up on top, and you will have 4 left over up on top. So there is no more fraction. It's simply a minus r to the 4th. You see how easy this works? And the last one, 40 divided by 5? 8. So 40 divided by 5 is 8. You're going to put that 8 up on top because the 40 was up on top. And then r squared, the 2 r's up on top completely cancel with 2 of these 4, and you'll have 2 left over on the bottom. So what do we have as our final answer? Plus 8 over r squared. There's your final answer. Now that's a heck of a lot easier than trying to do long division. Long division would be messed up right here. Because on long division, you have to represent every single power that's missing. So you'd have to represent the 9 with the 0 r to the 9th, 0 r to the 7th, 0 r to the 6th, 0 r to the 5. Like, forget it. That's ridiculous. So we are now able to do this first half of the worksheet, and I expect you to do so. Go ahead and pick 1 or 2 more to do right now in class. So would you like to do 2, 3, 4, 5, or 6?
5.
3? All right, let's do 3. You know what? 5 is pretty easy. I would rather do 6 compared to 5. 6 is way more fun than 5. Let's do 3 and maybe 6 if we have time here. So this guy is really underneath, right? Okay. And because it's really underneath, we could take each one of these, and because it's a monomial, we could split up each one of these terms to be over that divider. Yeah? So I'm going to rewrite this whole thing. Well, first of all, it's really over negative 6x squared y. And we're going to take each one of these, this one, and this one, and put them all over this divisor, negative 6xy. And you could only do that if you have a monomial. If you have a binomial, it's not going to help you. All right? So like, let me pause right here. Let's go to this problem over here. Imagine me trying to do that right here. Oh, 4x squared over 2x minus 3. I can't do anything. It doesn't help me at all, right? 2x over 2x minus 3. I can't do anything. So it would be pointless to split this divider up to each of these terms. It doesn't work. So only when it's a monomial. Right here, it's a binomial. It's 2 terms. There's a 2x and there's a 3. So only on like these problems on the first half where you have a monomial should you divide up that divisor into each and every term. So up on top, I have a negative 30 x to the third y, and then I have a plus 12 x squared y squared, and then I have a minus 18 x squared y. And these are all going to be fractions. I'm going to put them all over that denominator, negative 6x squared y. Does that make sense to everybody? And now it's really easy. You just start canceling terms out. So what is negative 30 divided by negative 6?
5.
Positive 5, right? So that's going to be a positive 5 up on top. That negative's gone. You got 2 x's on the bottom, which completely cancel with 2 of the 3 on top, and you'll have 1 left over up on top. And that 1y cancels with 1y, so there are no more y's. So your final answer is positive 5x. Actually, I should say the first part of your final answer is positive 5x. Let's move on to the second fraction. What is 12 divided by negative 6? Negative 2. So the 12 divided by negative 6 is negative 2, and I'm putting that negative 2 up on top. And then I have 1y, or actually I have x's. I have 2 x's up on top, 2 x's on the bottom. Both x's on bottom completely cancel with both x's up on top. And for the y's, the 1y that's on the bottom, that one's going to completely disappear with one of these 2, and you're going to have 1 left up on top. So what's my second term? It's going to be minus 2y. And for your final answer, the final part of your answer, what is 18 divided by negative 6? Negative 3. So that divided by that is negative 3. So keep that in mind. The x squared over x squared cancel. The x squared over x squared cancel. The y over y cancel. All you have left is positive 3. Minus 3 becomes positive 3, right? So I have positive 3. And that's it. There's my answer. Let's jump to number 6. So again, the negative sign, the negative exponent, means that I need to move it to the bottom of my fraction. Now, it's not a fraction right now, but I am going to rewrite it as a fraction. with the 4dk squared underneath all those three terms. So the next step would be to separate that division of 4dk squared to each of those three terms. Does that make sense to everybody? All I did was take this one, put it over that denominator, the middle one, put it over the denominator, the last one, put over the denominator. Also make note that the plus that was in front of the d squared, I put it out here in the middle of the fraction. The minus that was in front of the 4, I put it out here in the middle of the fraction. And now it's just a question of canceling things out. So on the first fraction, the 28 divided by 4 is 7. Of course, you have the 7 left over up on top. There's one d on the bottom that cancels with one of these d's up on top, so that would give us 2 d's left over up on top. 2 k's on top cancel with 2 k's on the bottom. So my final first part of my answer is 7d squared. Now the middle fraction, there's 1d on the bottom that cancels with one of these 2 up on top, so I'll have 1d left over up on top, and both k's on top cancel with both k's on the bottom. There are no more k's. So my middle term will be the fraction, the simple fraction d over 4. And of course you could write that as 1/4 d if you wanted to, but d over 4 is totally fine. And the last fraction, guess what? We have the same identical 4dk squared over 4dk squared. So what does that last fraction really end up as? -1, right? When you have the same exact thing on top over the same exact thing on bottom, everything cancels, you have a 1 left over. So this is what we call dividing a polynomial by a monomial, right? That's different than long division. This is way easier than long division. You could use long division on some of these, but it's ridiculously more challenging. Ladies and gentlemen, I know you guys are eager to just work, but the fact is, this is WSP 5.2 Part A, and there is a Part B, which I will do on the next video.